Hey there, students. Welcome to part 7 of the AP Calculus ED review multiple choice questions. We're going to be going over questions 81 to 85 in this review installment. All right, so let's take a look at 81. It says, let f be the function given by f of x equals the absolute value of x. Which of the following statements about f are true? Option 1, f is continuous at x equals 0. Option 2, f is differentiable at x equals 0, and the last option, f has an absolute minimum at x equals 0. So we can basically use our knowledge of the graph of the absolute value of a function, absolute value of x, to be specific to solve this problem. If you have forgotten what the graph looks like, you can always graph it using a graphing calculator. But to save time, it's good to have it memorized so you can sketch it quickly, okay? So this is what the graph of f of x equals the absolute value of x looks like. All right, so let's see which of those options are true. Is this function continuous at x equals 0? Absolutely. F of 0 is defined. So option 1 is a check. This is a continuous function. Option 2, f is differentiable at x equals 0. Now at x equals 0, we have a corner, a sharp corner. So know that differentiability fills at a corner, okay? The left-hand derivative is -1, and the right-hand derivative relative to 0 is +1. So left and right-hand derivatives are different. So what on earth is the derivative at this point? It's not defined. The derivative does not exist there. This function is not differentiable at x equals 0. So option 2 is false. Okay? And then option 3, you have an absolute minimum at x equals 0. So if I draw a neighborhood around this function at x equals 0, is x equals 0 the lowest point relative to every point? Well, it says absolute. So if you look at this function, it goes up forever in both directions. So this is the absolute minimum of the entire function. All right, so that is true also. All right, so since the only false statement is 2, our answer is going to be option B. Okay, 2 is the only one that's false. All right, let's shift our attention to question 82. Question 82, we've been tested on integration here, and also the use of substitution and evaluating integrals, and the understanding of the relationship between a function and the antiderivative, and how the antiderivative interacts with the integral. Okay, so we have to find the integral from 1 to 3 of f of 2 of x dx. Okay, we also told that f prime of x is equal to f of x. So let's go ahead and input that here. So we're going to have the integral from 1 to 3 of f prime of 2x. Okay, because we know that f of x is equal to f prime of x dx. All right, so how do we integrate this? Well, before we start, we notice that we have to use substitution here because this is a composite function, okay? So what we're going to do is we're going to say let u be 2x, okay? If u is 2x, then du is going to be 2 dx, which means that du over 2 equals dx, all right? So when we're making a substitution for this inner function right here, we have to also adjust dx to compensate for the chain rule, all right? So let's go ahead and make the substitution. So we're going to have the integral from 1 to 3. This is still x limits of f prime of u. Now, replacing 2x with u requires us to replace dx with du over 2 times du over 2, okay, which equals 1/2 factor of the integral of 1 to 3, the definite integral from 1 to 3 of f prime of u du. Okay? All right, now what is this going to be? Well, we know that the derivative and the integrals are inverse operations, right? So if you take the antiderivative of this function, it's just going to cancel out that derivative. So this is going to be 1/2 times f of u evaluated from 1 to 3. Okay? Now, can I plug my limits of integration in? That's a question. So the answer is absolutely not, because these are x. Okay, x equals 1 all the way to x equals 3, but this is still u, so they're different variables. Okay, so if we wanted to change our limits of integration, what we can simply do is I can either change this back to 2x, or I can double the limits. Okay, so let me change it back to 2x. So everything is in terms of x. It doesn't really matter how you do it. So it's going to be f of 2x from 1 to 3. Now I can make use of FTC part 2. And this is going to become 1 half times f of 2 times 3. You see that we're doubling the u right there like we did up there, minus f of 2 times 1. All right? And then that's how it is. Simplify a little bit more. You can distribute the 1 half. You can have 1 half times f of 6 minus 1 half times f of 2. Okay? So you can clearly see that our answer to number to number 82 is option E. All right, so there you have it. All right, moving along. Okay, so question 83 is assessment understanding of limits, double-sided limits of a function with discontinuities. So we have to find the limit at x as x approaches a of x squared minus a squared over x to the 4 minus a to the 4th. Okay, we know that when a is 0, there's going to be discontinuity there, but the question is it an infinite discontinuity, which means the limit will not exist, or is it removable, which indicates that the limit does exist? So what we have to do is simplify this expression as much as possible and see if we can find the limit. Okay, we don't want to be in a haste to conclude that the limit does not exist. That will be true if the discontinuity were infinite. Okay, all right, so let's go ahead and factor this as much as we can. We're going to use the difference of squares formula that you learned in algebra to factor this. So the numerator can be factored into x minus 2, oh, sorry about that, x minus a times x plus a. And how about do x plus a times x minus a? And then in the denominator, we'll factor that into x squared plus a squared times x squared minus a squared. Okay? So we're just using the formula, the difference of squares formula. Remember what it is. A squared minus b squared factors into the sum and the difference of the square roots of these two. So a plus b times a minus b. That's what I'm using here. Okay? Okay, let's see. We have a difference of squares here again. So that means that we can actually factor it further. So this becomes limit as x approaches a of x plus a times x minus a over x squared plus a squared. This factors into x minus a times x plus a. So let's see. The x minus a cancels out like that. And what we're going to do now is also cancel out the x plus a's too. X plus a, here goes 1, x plus a goes here 1. And can finish it off. Now let's plug in a in there. Notice there isn't any complications. We plug in a here, which tells us that the discontinuities plus or minus a were removable in this function. So now let me just show you the intermediate step. We have the limit as x approaches a of 1 over x squared plus a squared. And then when you plug in a, you have 1 over a squared plus a squared, which equals 1 over 2a squared. So our answer is option B. Okay, now let's move on to question 84. In question 84, we're told that a population y grows according to the equation dy dx equals ky, where k is a constant and t is measured in years. If the population doubles every 10 years, then the value of k is. Now, what we have to do is we want to find the equation that models this growth. Okay, so this is a differential equation. The y, the t equals ky. So what function has a growth rate that is captured by this formula of this differential equation? So we have to solve this differential equation first, and that will give us the function that we can use to actually find the value of k, okay? All right, so we're going to solve this by separation of variables. Pretty easy to do here. So we have dy, divide both sides by y over y equals kt. All right, and then just integrate both sides of the, well, we could just, how about just integrate the left side of the equation? This is not a, this is just a term, it's not an integral. So we integrate this side, dy. So what is the antiderivative of dy over y? Or you can look at this as an integral of 1 over y dy. Okay? So what is the antiderivative of 1 over y? It's natural logarithm of y. Okay? Natural logarithm of y um, plus c equals kt. All right, so we want to get the function that describes this growth, that has this growth rate, has this rate of growth. So we need to get y by itself, okay? So subtract c from both sides. We have the natural logarithm of y equals kt minus c. And then to isolate the natural logarithm, you just exponentiate both sides using e as the basis of exponentiation. So e to the ln y equals e to the kt minus c. And now we have, all right, so 84. That says the population y grows according to the equation dy dt equals ky, where k is a constant and t is measured in years. If the population doubles every 10 years, then the value of k is. Now, in order to find the value of k, we need to find the equation that has this growth rate, okay? So there is an equation that when you differentiate it, you get this equation right here. So the question is, what is that equation? So we have dy dt equals ky. So this is a differential equation. The solution of this differential equation is the equation we can use to solve the problem, okay? So how do we solve this differential equation? This is an equation that can be solved by separation of variables, all right? So let's go ahead and separate the variables. Y is on the left and t on the right. Remember, k is a constant. Okay, so we have dy over y equals k dt. So what we just simply do is we're going to integrate both sides, integrate the left and integrate the right, and then we're going to have on the left side the natural logarithm of y, natural logarithm of y equals, and then on the right side kt, and then plus c. All right. So let's say c is a constant that's been added to both sides. So we can write it like this. All right. So what we're going to do next is solve for get y isolated. So to do that, we're going to exponentiate both sides using e as the basis of exponentiation. So e to the ln y equals e to the kt plus c, and then these cancel out, and then you have y equals e to the kt plus c. Now we're going to do some algebra here just to determine what the initial, the formula, the term for the initial amount, okay, the initial population. So to do that, using the product property of exponents, the reverse of it, we can express this exponent as e to the kt times e to the c. Remember, whenever you're multiplying exponents of the same base, you add the powers, right? So if you have a sum of powers, you can express it as a product of exponents with the same base as we have here. All right, so now we can let e to the c be the initial amount. So let e to the c is a constant equals y sub 0. Okay, this is the initial population. You could call it p sub 0, doesn't make any difference. Initial population. All right. Okay. So trying to stay consistent with the variables here. So our function that we're talking about, y of t is equal to y of 0 times e to the kt. Now this is the equation, population growth exponential equation that we can use to solve this equation for k. Okay, so how do we go about it? We're told that the population doubles every 10 years. So if you go from 0 to 10 years, the population will double. So if we're doing that here, we're just gonna say at t equals 10, what happens at t equals 10? Y sub 0 doubles. Okay? Remember, the final amount is y sub t, the initial amount is y sub 0. So if y sub 0 is equal to y sub 0 initially, after 10 years, the final amount y sub t is going to simply be double the initial amount y sub 0. Okay? We don't know what the initial amount is, but we don't really need it, as you'll see momentarily. All right? So I'm going to plug in these two values into our equation as long as t equals 10, and we're going to have the exponential equation 2 times y sub 0 equals y sub 0 e to the k, which is what we're looking for, times 10. Okay, this equation just simply tells me that at 10 years, the initial amount doubles. All right? Okay, so how do we solve this? Divide both sides by y sub 0 on the left and on the right. Okay, we're just solving a basic exponential equation here. So these cancel out, these cancel out. You have 2 equals e to the 10k. We need that k isolated, so we take the natural logarithm of both sides. These two cancel out, so we have 10k equals the natural logarithm of 2. And then divide both sides by 10, you have k equals the natural logarithm of 2 divided by 10. All right, so we need our calculator to do this because our options are in decimal form. All right, so we're going to compute the natural logarithm of 2 divided by 10. So I have to hit that one enter to give me an approximation. So it's 0.069 to 2 decimal places. So k is approximately 0.069. And we can clearly see our answer is option letter A. Okay, so there you have it. All right, let's take a look at question 85. Question 85, we're told that the function f is continuous and equals interval 2 to 8 as illustrated in this table and has the values that are given above. Using intervals 2, 5, 1, 5, 7, 2, 7, 8, 3, that's 3 subintervals. What is the trapezoidal approximation of the integral of the function from 2 to 8? Okay, so we're using a trapezoidal approximation here. So if you look at the way it's partitioned, we have 3 trapezoids, okay? And we know what the formula for the area of a trapezoid is, right? So the area of a trapezoid is basically 1/2 times base 1 plus base 2 times the heights, the 2 parallel bases, 2 parallel sides times the height, okay? So that's what we're going to be doing here. All right, so we have 3 trapezoids here. So in order to determine the area, so we're going to use the following formula, the integral from 2 to 8 of f of x dx is going to be area of trapezoid 1, which is 1 from 2 to 5, plus area of trapezoid 2, plus area of trapezoid 3. Okay? We'll do them individually. Well, what's the area of trapezoid 1? 1/2. Same, the bases are basically how high it goes from the x-axis to the point on the graph, and that's f of x, basically. Okay? So it's going to be 1/2 of f of 2 plus, that's the first side, and then the second base is going to be the next point, f of 5, times the height. The height is going to be the change in x. Okay, so that's going to be 5 minus 2. Okay, so this is the area of T1. Let's go ahead and work this out while we're at it. So it's going to be 1/2. F of 2 is 10. F of 5 is 30. 5 minus 2 is 3. Equals 1/2 of 10 plus 30 is 40. Times 40 times 3. 2 goes here, 1, 2 goes here, 20 is basically 60. Okay? Alright, how about area of trapezoid 2? Area of trapezoid 2 is adjoining area of adjoining trapezoid 1. Trapezoid 2 and trapezoid 1 share a common side. Okay, so B2 of trapezoid 1 is B1 of trapezoid 2. So we're going to have 1/2 of f of the left the left side of trapezoid 2, which is the right side of trapezoid 1, which is f5, plus f7. Okay, we're going now with the second subinterval 5 to 7 times the height, which is a change in x. Okay, so that's going to be 5, I'm sorry, 7 minus 5. Let's work this out. So it's going to be 1/2 times f of 5 is 30, plus f of 7 is 40. 7 minus 5 is 2. These two 2's cancel out conveniently. So area of trapezoid 2 is 7, 0. Okay, and then we need area of trapezoid 3. So let's see. We have area of trapezoid 3 equals 1/2 of the left side of the left base of trapezoid 3 is the same as the left base of as the right base of trapezoid 2, so f of 7 plus the right side, the right base is f of 8. That's the third subinterval times the height is basically the change in x, so that's going to be 8 minus 7. All right. Okay, so that's going to be 1/2. F of 7 is 40 plus 20 times 1. Okay, and that let's see, simplifies into 1/2 of 60, which is just 30. Okay, so the area under the function approximating with trapezoids is approximately 60 plus 70 plus 30, which is approximately 160. Okay, so that goes your answer for the trapezoidal approximation of the area under this curve. All right, so there you have it. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here, and please post a comment to let me know what you think about this presentation. Any questions that you still have, you can just put it down here. I'll be glad to answer it. More clips can be found on myblogserve.com. Thanks again, and have a wonderful day.